Okay, example number 3. Example number 3 is tricky again, but for a different reason. This one's tricky because they're asking you to describe where y equals sine x is increasing. And you guys are all familiar with y equals sine x. You know, the function looks like this, roughly. It's periodic, it repeats. And because it's periodic and it repeats, its intervals of increase and decrease also repeats. And so the question of where it's increasing, you know, it's going to have many intervals. In fact, an infinite number of intervals that you need to be able to describe. And so that's what makes this problem tricky. So again, process is very similar, but it's tricky because it's a periodic function. So we start by taking the derivative. Derivative of y equals sine x is just cosine x. Put that to the side here. And actually underneath, I'm going to grab some things that I drew earlier. So here, oops. Here's the graph of cosine. I've drawn it from about negative 4 pi to positive 4 pi. And then underneath, I also have a circle. The question of where sine x is increasing is the same question as figuring out where cosine x is positive or 0. Okay, so we need to look at the cosine function, the derivative, and see where it's positive or 0. It's positive, it seems, here between 0 and what value is that? That's going to be pi over 2. And then it seems to repeat, like that same interval from 0 to pi over 2 repeats 2 pi later. And then it repeats again 2 pi later. And then you can subtract 2 pi, and then it repeats again. So you're seeing the same interval, but just repeating over and over again. In fact, what you're seeing is, remember cosine, this cosine function represents the ratio of the x coordinate to the radius on a circle. And the intervals in blue that I've highlighted are actually these intervals, from 0 to pi over 2. The x-coordinate is positive, and because of that, cosine is positive. But you can keep adding 2 pi to it, and you'll land back in the same spot on the circle. And so you're getting these repeating intervals, I should say. And then we can also do these intervals. So from negative pi over 2 to 0, we seem to have something similar happening. And then you can add 2 pi to that. And then add 2 pi, subtract 2 pi, you know, and so on. And what you'll end up noticing is that you're getting this interval on quadrant 4. And cosine is positive there. But you're just getting repetitions of that. Okay, so how do we determine where sine x is increasing? Well, we know that it's going to be increasing on an infinite number of intervals. We just need to be able to describe it. And we know that it's linked to when cosine x is positive or 0. So what we need to do is really figure out when cosine x is bigger than or equal to 0. So cosine x is bigger than or equal to 0 when... and I think that there are many ways to do this. One way to see it is, well, it's clear, and you can kind of see it from the graph. You can also see it from the diagram below. It's clear that cosine x is positive or 0 from negative pi over 2 to positive pi over 2. So in the interval from negative pi over 2 to positive pi over 2, it's clear that cosine x is bigger than or equal to 0. But this interval repeats. Like you can add 2 pi to it, keep adding 2 pi, or subtracting 2 pi, keep subtracting 2 pi's. And so really, I'll make a note, but this repeats. And it repeats every 2 pi radians. And so the correct interval now is going to be the interval from negative pi over 2 plus some 2 pi k all the way up until pi over 2 plus some 2 pi k. Okay, and k here is an integer. So here what we're doing is we're adding multiples of 2 pi, subtracting multiples of 2 pi to capture all the intervals where cosine x is either 0 or positive. Okay, so the you might see in the textbook they might combine this into a single fraction. I'm not going to do that to simplify. But other than that, that's kind of the general concept. This question is tricky again, not because of the calculus, but because of this whole nature of periodic functions and their ability to repeat. So hopefully the 3 examples all added some kind of value. Even though on the surface this topic is not difficult, the kinds of functions that you have to deal with can be. And so hopefully you've seen enough examples now that you're confident at doing some of the questions today. Okay, have a good rest of your day. Stay safe.